My name is Brenda. I'm currently working on quantifying the threshold of the Module-Lattice-Based signature algorithm in a restrained, or I would say constrained environment. Now, to be more precise, it's a post-quantum authentication scalability for the Australian myID. Now, why this research method? A real migration problem. Classical identity credentials must eventually coexist with the post-quantum security. Now, the current system uses the RSA 2048 algorithm, which, if we talk about the quantum computers, could easily crack. They could decipher those algorithms. So, even the Australian government wanted to move to the post-quantum algorithms by the end of 2030. The post-quantum candidates NIST-FIPS 2004 standardizing the ML-DSA for the digital signatures, designed to retain secure against large-scale quantum adversaries. Now, what the current myID system looks like and what are the research gaps that are established. So the public domain explain the identity proofing federated roles, but not the performance impact of the post-quantum migration. They have the user mobile, the myID which actually verifies the user identity, then the digital ID exchange that connects those services to the actual Reliance services which we wanted to access, like MyGov. Now, the gaps that I have identified from the public resources were the ML-DSA security is a standardized, but its system level goes in the myID like federated authentication workflow is not quantified. Public material does not give the concurrency threshold at which the CPU memory or the network constraints cause service degradation. The migration guidance needs evidence about scalability and not only about the cryptographic correctness. Now, aims and the questions that I have come up with so far. Now, my aim was to build a simulated working environment for the myID system. I came up with these questions. Question number one, how does the myID change signing verification end-to-end latency and throughput compared with the RSA? It also talks about dealing with what is the size of the music clarity keys generated by ML-DSA and comparing it with the RSA that the current system has. Question number two, what is the highest stable authentication rate before the latency target or the reliable criteria are violated? Third, does the CPU memory or the network capacity, which one of them becomes the first bottleneck problem? Then the scalability design. What are the architectural choices for this system? Now, reproduce testbed and measurement, simulated mobile client, identity provider API, crypto services. I have established four. One, the original RSA 2048, ML-DSA 44, 65, and 87. Exchange mocks and reliant party. Measure them in P95 and P99. So, what is the percentage uh, of the approval rate? And then the auth, CPU memory, and the network bits. The tooling was used like Docker Compose for the reproducibility, K6 for the control arrival fleet loads, per stage timing, container resource metrics, and repeated runs with the fixed controls. Now, what my current phase of the research is, I am currently checking the CPU and the memory limits. So, changing my Docker configuration like one CPU and 128 megabytes and providing it with certain requests. Currently, I have established it between 400 to 2000 and it fails around 2000. So I'm working on to find the middle ground. And moving on to the next slide, the progress so far. So current system research done, RSA ML-DSA cryptographic baseline done, federated auth testbed done, loads plus metric instructions done. I'm working on the CPU and memory experiments, and then I'll be moving on to the network and the final analysis. Now the analysis plan, contribution, and the next steps. So how I will identify the bottleneck. The CPU bottleneck, utilizing the saturated queues, grow more cores, raise capacity. Memory bottleneck, working set approach limit, GC behavior appears, more RAM, raises capacity. Network bottleneck. Throughput approaches the imposed limits while the CPU remains low saturation. Now, planned output, comparing the RSA and ML-DSA latency and the throughput, maximum sustainable authentication per resources profile, CPU memory, and network curves, signature size, and transportation overhead across the network, threshold confidence from the repeated run. The expected research contribution: a reproduced method for testing a post-quantum authentication under a constrained resource, plus designing the recommended station for the cryptographic agile and horizontal scalability digital identity service. Now, next step would be moving and checking the middle ground of when the CPU and the memory threshold fails and designing a matrix on that. So I would say the target outcome is at what load does the post-quantum authentication stops being reliably scalable, why, and what should a future digital identity architecture do about it. These are the references for my presentation and the resources that I have been using for my research. Thank you.